today we're diving deep into the world of artificial intelligence. We're talking about the pioneers, the legends, the godfathers of AI. These are the minds that didn't just dream about the future of AI, they built it. So if you're ready to explore the incredible journeys of Geoffrey Hinton, Yann LeCun and Yoshua Bengio, the three figures who revolutionized AI, buckle up. This is going to be an epic ride.
First up, we have Geoffrey Hinton, often referred to as the Godfather of deep learning. His contributions to the field are nothing short of revolutionary. Now, if you're thinking deep learning, that sounds intense, you're not wrong. It's a complex and fascinating area of study. Hinton's work is the bedrock of many AI applications we use today, from voice assistants to image recognition software. These technologies have become integral to our daily lives. We're talking about the tech that lets your phone understand your voice commands, the algorithms that power self-driving cars, and even the systems that recommend your next binge-worthy show. It's all thanks to the foundational work of Hinton. Yeah, Hinton's impact is everywhere. His influence can be seen in countless innovations and advancements in the field of artificial intelligence. His journey began back in the 1970s when AI was still in its very early stages. It was a time of great curiosity and exploration. Back then, the idea of machines that could learn like humans seemed like something out of a sci-fi movie. But Hinton was hooked. He saw the potential and was determined to explore it. He was fascinated by the potential of neural networks, systems inspired by the human brain that could process information in a fundamentally different way than traditional computers. This was a groundbreaking concept. Now, the concept of neural networks had been around for a while, but they were really difficult to train effectively. The challenge was immense. That's where Hinton made his mark. He was relentless in his pursuit of solutions. He championed a technique called backpropagation, which essentially allowed these networks to learn from their mistakes and improve over time. This was a pivotal moment in AI research. Think of it like this. Imagine teaching a dog a new trick. It's a process that requires patience and repetition. You don't expect them to get it perfect on the first try, right? It's a gradual learning process. You use positive reinforcement, correcting their mistakes and rewarding them when they get it right. This method is effective and encouraging. Backpropagation is kind of like that, but for neural networks. It was a game changer. It allowed for significant advancements in the field. Suddenly, neural networks could tackle much more complex tasks, and Hinton's work laid the foundation for the deep learning revolution that was to come. This was a monumental shift, but it wasn't always smooth sailing. The journey was fraught with challenges and obstacles. In the 80s and 90s, deep learning faced its share of skepticism. Many doubted its potential. The computers back then just weren't powerful enough to fully realize the potential of Hinton's ideas. The technology was lagging behind the vision. It was like having a super-fast car but no roads to drive it on. The infrastructure just wasn't there yet. But Hinton, he never gave up. His determination and perseverance were unwavering. He kept pushing the boundaries, refining his theories, and mentoring a new generation of AI researchers. His influence extended far beyond his own work. And then, something amazing happened. A breakthrough that changed everything. Around the mid-2000s, computing power caught up. The technology finally matched the vision. We're talking massive advancements in processing speeds and the availability of huge datasets. These were critical developments. Suddenly, those super-fast cars had the open road they needed. The possibilities were endless. Deep learning exploded onto the scene, and Hinton's work was at the forefront. His contributions were finally being realized on a grand scale. His research helped unlock breakthroughs in speech recognition, image classification, and natural language processing. These advancements have transformed numerous industries. Today, Geoffrey Hinton is a living legend in the world of AI. His legacy continues to inspire and drive innovation in the field.
Next up, we have Yann LeCun, a name synonymous with computer vision, the field that enables machines to see and interpret images, much like humans do. If you've ever used facial recognition to unlock your phone, or seen a self-driving car navigate a busy street with ease, you've witnessed the power of LeCun's work firsthand. His contributions have made these technologies possible. LeCun's journey began in France, where he was captivated by the idea of building machines that could learn and understand the world through images, just like humans do. This fascination drove him to explore the depths of artificial intelligence. He dove deep into the world of neural networks, but he quickly realized that traditional approaches weren't going to cut it for the complexities of vision. See, Images are messy and unpredictable. They're full of variations in lighting, angles, and objects that can trip up even the most sophisticated algorithms. This variability posed a significant challenge. LeCun knew there had to be a better way. He was determined to find a solution that could handle these complexities. And that's when he struck gold. His relentless pursuit of innovation paid off. In the late 1980s, LeCun developed a revolutionary type of neural network called a convolutional neural network, or CNN for short. Now, I know that sounds like a mouthful, but trust me, it's a big deal. CNNs changed the game. CNNs were specifically designed to process images in a way that mimicked the human visual system. This was a groundbreaking approach. They used a special type of mathematical operation called convolution, which essentially allowed the network to learn and identify patterns in small, localized regions of an image. This made them incredibly efficient. Think of it like this. Imagine you're trying to identify a cat in a picture. Instead of looking at the entire image at once, you might focus on smaller details first, like the shape of its ears, the texture of its fur, or the position of its eyes. This method is much more manageable. CNNs work in a similar way, breaking down images into smaller, more manageable chunks. This approach was groundbreaking and highly effective. CNNs were incredibly effective at recognizing patterns, even in noisy or distorted images. They could handle a wide range of visual data. They could identify objects, faces, and even handwritten digits with remarkable accuracy. This opened up a world of possibilities. LeCun's work didn't just stay confined to research labs though. It had real-world applications. In the 1990s, he joined Atanditi Bell Labs, where he led a team that developed some of the earliest commercial applications of CNNs, including a system that could read handwritten checks. This was a significant milestone. That's right, your bank might have LeCun to thank for making sure your deposits end up in the right place. His innovations had a direct impact on everyday life. But LeCun's vision extended far beyond check-reading machines. He saw the bigger picture. He knew that CNNs had the potential to revolutionize entire industries. And he was right. His foresight was remarkable. Fast forward to today, and CNNs are the backbone of countless computer vision applications. They are integral to modern technology. They're used in everything from medical imaging to self-driving cars to facial recognition systems. The impact is vast and varied. LeCun himself has remained at the forefront of AI research. He continues to push the boundaries of what's possible. His work has not only advanced the field of AI, but has also raised important questions about the ethical implications of these technologies. The conversation he started is ongoing and crucial.
And last but certainly not least, we have Yoshua Bengio, a true visionary in the world of deep learning and a champion of unsupervised learning, a field that has revolutionized how we approach artificial intelligence. Now, if you thought supervised learning was complex, unsupervised learning takes things to a whole new level, pushing the boundaries of what machines can achieve. See, in supervised learning, we feed algorithms labeled data. We tell them, this is a picture of a cat, or this is a recording of someone saying hello. But in the real world, a lot of data is unstructured and unlabeled, making it a challenge for traditional AI systems. Think about all the text on the internet, the images on social media, or the sensor data from your smartphone. Bengio's big question was, can we build AI systems that can learn from the vast sea of unlabeled data without explicit instructions? Can we create machines that can discover patterns, make connections, and generate new ideas on their own, much like a human brain? That's the essence of unsupervised learning, and it's a field where Bengio has made groundbreaking contributions, pushing the envelope of AI research. His work has focused on developing new algorithms and architectures that allow machines to learn representations of data without being told what to look for. One of his key areas of focus has been generative AI, a field that aims to create AI systems that can generate new content, like images, music, or even text, that's indistinguishable from human-created content. Think about the potential here. AI that can compose original music, write compelling stories, or even design new products, opening up endless possibilities. Bengio's research has been instrumental in advancing this field, laying the groundwork for future innovations. He's developed novel techniques like generative adversarial networks, which pit two neural networks against each other in a kind of AI arms race to generate increasingly realistic and creative outputs. But Bengio's impact extends far beyond his technical contributions. He's also a passionate advocate for ethical AI development, ensuring that the technology serves humanity positively. He recognizes that as AI becomes more powerful, it's crucial that we develop these technologies responsibly and ensure they benefit all of humanity. He's been a vocal critic of AI bias, emphasizing the need for fairness and inclusivity in AI systems. He's also spoken out against the potential misuse of AI for malicious purposes, calling for greater transparency and accountability in how these technologies are developed and deployed. Today, Yoshua Bengio is a global leader in the AI community, influencing the direction of AI research and policy. He's the founder and scientific director of MILA, the Quebec AI Institute, one of the world's leading research centers for artificial intelligence, fostering innovation and collaboration in the AI field.
So there you have it, the incredible journeys of Geoffrey Hinton, Yann LeCun and Yoshua Bengio, the godfathers of AI. These three brilliant minds have not only shaped the technological landscape we live in today, but they've also paved the way for a future where AI has the potential to solve some of humanity's greatest challenges and problems. Now, I'm curious to hear from you. Which godfather's work resonates with you the most, and what are your thoughts on the future of AI? Let's discuss it in the comments below. If you're as fascinated by the world of AI as I am, hit that subscribe button and turn on notifications so you don't miss out on future deep dives into the tech that's shaping our world. Subscribe for more AI, tech and innovation content. Subscribe to our channel and stay updated about the latest breakthroughs and discoveries.